Today, I wanted to present a special topic that is introduced in your textbook in Chapter 2 and is revisited in Chapter 8, and is quite prominent through chemistry. There's a specific type of compound known as a hydrocarbon, and hydrocarbons undergo a different type of naming procedure than other typical binary compounds. So I just wanted to speak for just a moment on hydrocarbons and how we name them. Now, many of you who go beyond General Chemistry 1 and General Chemistry 2 will find yourselves dipping your toes into the world of organic chemistry. Organic chemistry, in short, is the study of carbon and carbon-containing compounds. Well, there's a class of compounds that are simply made up of carbon and hydrogen. These compounds are called hydrocarbons. While these compounds are introduced in Chapter 2, the structure of these compounds is something that we don't really find out about until Chapter 8, because we don't know how to draw Lewis structures just yet. So bringing those two chapters together and moving ahead to the future, we're going to talk very briefly about these hydrocarbons. Now, the simplest type of hydrocarbon is known as an alkane. An alkane involves carbon surrounded by hydrogens. Now, it could be as simple as one carbon and four hydrogens to complete the octet, or, as you can see at the top of the slide, two carbons that are bonded together via single bonds with enough hydrogens to complete the octet around each, or three carbons or four carbons ad infinitum. So how do we name these compounds? Well, the naming comes from two parts. The first part indicates the number of carbons that are present. One carbon would have a prefix of meth, M-E-T-H. Two carbons would be F, E-T-H. Three carbons would be prop, and so forth and so on. The second part of the name is simply the letters A, N, E. So a one carbon species that is a hydrocarbon, specifically an alkane, would be called methane. A two carbon alkane would be called ethane. Three carbons, propane. Four carbons, butane, but I think I'm getting ahead of myself as far as the naming of these compounds. And typically we find that they are of a basic formula, CnH2n plus 2. So however many carbons there are are going to be twice as many hydrogens plus 2. All right, so the number of hydrogens will be 2 times the amount of carbons plus 2 more hydrogens to complete. So as far as those prefixes are concerned, here we see a list of the first 10 prefixes. 1 meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So if we were talking about a 7 carbon hydrocarbon, specifically an alkane, we would call it heptane. An 8 carbon alkane would be known as octane. Vroom vroom. Now, alkanes are not the only type of hydrocarbon. In alkenes, we see the presence of at least one carbon-carbon double bond. Now, they're going to be named similarly in that it's going to break up into two parts. The first part based on the number of carbons, and the second part being simply the letters E-N-E. Now, you'll notice that As far as the prefixes are concerned, I didn't start by mentioning meth at 1. Well, it would be impossible to have a 1-carbon alkene since the presence of a carbon-carbon double bond indicates an alkene. So the first possible alkene, numerically speaking, would be ethene, followed by propene and butene. Here at the top of the slide, we see ethene and hexene, specifically 1-hexene. Now it's called 1-hexene because the double bond is placed on the first carbon. If it were placed between the second and third carbon, then we would call it 2-hexene. And alkenes are typically of the formula CnH2n. So there are twice as many hydrogens as there are carbons. If you look at the formula for ethene, it is C2H4. If you look at the formula for 1-hexene, we see C6H12. The last type of hydrocarbon that we're going to speak of are called alkynes. Alkynes have at least 1 carbon-carbon triple bond. So once again, we're going to see the same basic naming scheme with prefixes followed by YNE. So a 2-carbon alkyne would be called ethine. A 3-carbon, as is seen at the top of the slide, is called propyne. And the formula for an alkyne is CnH2n-2. So as we see, propyne has the formula of C3H4. Now, while not strictly a hydrocarbon, we see modification of hydrocarbons that are quite important in organic chemistry. When a hydrogen in an alkane is replaced with something else that ultimately we're going to call a functional group, like an OH group in the compounds listed at the top of the slide, the name is derived from the original alkane. So in the first instance, we see what would have been CH4 methane. But since we see the removal of a hydrogen replaced with an OH group, the ending is going to be reflective of that functional group. Alcohols end in OL. So, as we see at the top of the slide, we see an alcohol whose basic alkane was methane, so we call it methanol, followed by ethanol, followed by propanol. Now, once again, we see 1 propanol as opposed to 2 propanol. 1 propanol suggests that the OH group is on an exterior carbon, as opposed to the carbon in the middle, which would be the second carbon. So we would refer to that type of alcohol as 2-propanol. If that didn't truly sink in, then please take a look at the right-hand side of this slide, where you will see images of 1-propanol and 2-propanol. The formulas are the same. They both have the formula of C3H8O. When 2 or more molecules have the same chemical formula, but they have different structures, these molecules are called isomers. So 1-propanol and 2-propanol are isomers of one another. It should be noted that while these molecules look similar and have the same chemical formula, that in fact they can have different chemical and physical properties. For example, 1-propanol and 2-propanol have different boiling points. And I was able to cover that special topic in less than 10 minutes. Oh, wait, this sentence means that I went over 10 minutes, just so ever so slightly. Oh well. Thank you for your time and have a great day.